Here we go. We are trying to factor out the GCF. I want to see what things do they all have in common. So there are two parts up here. I've got this and I've got that. I want to see what they all have in common. Okay, so the first thing I'm going to do is look at each part and try to figure out what they have in common. So the first thing I've got here is a number. I've got the number 8 and 20. I need to think, what number can I take out of 8 and 20? What number could I divide both 8 and 20 by? Okay, and the answer is the number 4. Okay, I can take out a 4 out of both things. Sorry, that was giant. 4. Okay, the next thing I'm going to do is look at the next part. So the next thing I've got here is I've got an x cubed and an x squared. So I need to think, what can I take out? Okay, what's the smallest thing, or what's the biggest thing they both have in common? Well, they both at least have an x squared. Okay, they both have at least an x squared, so I'm looking at exponents. So since at least I have an x squared, I can take an x squared out of both things. Next thing, keep on going down the line. So I just did x's, now I'm going to do y's. This one has 1 y, so if that one only has 1, the most I can take out is 1. And this one has y to the 4th. That means I can take out 1 y, because this one's only got 1. I can take out 1 y out of both things. So I'm going to take out 1 y. And then finally look at the last part here. So I've got z to the 4th, so I can take out 4 out of that one. But this one I can only take 3 out of. So I'm going to take z cubed out of both things. Okay, so here's what I'm doing. Out of both things, I'm taking out a 4, an x squared, a y, and a z cubed. So it's like I'm dividing both chunks here, by that. 4x, y, z cubed. So if I take an 8 divided by 4, that would leave me with 2 in this first chunk. If I took x cubed divided by x, that leaves me with x squared. If I took out the y, then there wouldn't be a y anymore. And z to the 4th divided by z cubed. If I take 3 out of 4 of them, I would have 1 of them left over. Then I would do the same thing with the second one. I've got a 20. I'm dividing it by 4. So there's a plus sign in the middle, but 20 divided by 4 would get me 5. If I have an x squared and I take an x squared out, I wouldn't have anything left over. If I have the y to the 4th and I take out a y, I'd have y cubed. And if I had a z cubed and I took all z cubed out of it, I wouldn't have a z anymore. This is my answer once I factored out z by GCF. What did they have in common? And then divide it out to see what you have left over. Number 2 says factor and solve. Okay, anytime I'm trying to factor, I always want to look first to see if they have anything in common. So just like the last problem. I've got an x cubed here and a 9x there. Is there anything that they both have in common? Well, they both have at least an x in them, so I can take an x out of both things. So it's like I'm going to divide an x out of both. If I take an x cubed and divide an x out, I'd have x squared left over. If I had a 9x and I took an x out, I wouldn't have any x's anymore. It would look like that. Okay, so I factored it. Okay, I factored it, and I'm going to solve from there. Okay, it's equal to 0, so I'm going to take each chunk here and set both chunks equal to 0. This one's done. X is equal to 0. X is by itself. This one I got to do a little work. I'm going to subtract 9 from both sides. Then I'm going to square root to get rid of the x squared. That leaves me with x. If I square root -9, anytime I take a square root, it's plus or minus. The square root of 9 is 3, but because of that negative sign in there, remember we can't take the square root of negative numbers, there's got to be an imaginary number. So my 3 answers to this problem, and I knew there were going to be 3 answers because it was x cubed. Okay, because of the cube up there, that tells me I have 3 answers. 1, and then plus or minus 3i. That gets me my other 2 answers. Number 3, factor by grouping. Okay, this might be the hardest thing, even though it's not hard. Okay, factor by grouping means this. You're going to break this polynomial. Okay, it's a polynomial. We're going to split it into 2 parts. This part and this part. All right, and what we're going to do with these 2 parts is we're going to look at them, and just like before, we're going to factor out what they have in common. So in this first part, what do these 2 things have in common? Well, I can't divide anything out of 3 and 2 because 2 doesn't divide by 3, so that doesn't work. But they both have at least 2 x's in them, so I'm going to factor out an x squared. If I factor out an x squared, okay, if I take an x squared out of this, that doesn't change the 3 at all. If I take an x squared out of x cubed, that would leave me 1 more x. I'm going to do the same thing with the second one. I'm going to take an x squared out, just like we took out before. If I take a 2, there's nothing to take that 2 out, so it's still plus 2. But if I take an x squared out, I wouldn't have anything left over, so it's just that. We're going to do the same thing with the second chunk. Okay, so looking at this second part here, I'm looking to see what these 2 things have in common. So 15x plus 10, they both, I can divide a 5 out of both of them. I could take a 5 out of 15x. If I divided 15x by 5, it'd leave me with 3x. If I divided 10 by 5, it would leave me plus 2. Notice that these 2 things, when I factored them out, if you did it correctly, when you factored it out, these 2 chunks right here should be exactly the same. They're both 3x plus 2. And what we can do from here is we can then make 2 separate factors. 2 separate factors. One factor is going to be the one that we have, okay, 3x plus 2 right at one time. And then my other factor that I get comes from the things we took out. So this one's going to have an x squared in it, and this one's going to be 5, and since it's positive, it'd be positive 5. That is factored by grouping. Might be the hardest thing that we do. If you're struggling with that, just keep getting better at it. Number 5, we're subtracting. This is exactly what we did the other day. You see a minus sign in front of parentheses, we are going to distribute the minus sign. Okay, so a minus sign in front of parentheses, we're going to distribute the minus sign. In other words, think I'm going to change every single sign after that minus sign. That's what distributing that negative means. Each of these things is going to change signs. Okay, so this first part remains the same. 4x squared plus 9x cubed minus 2x plus 3. Nothing changed that. Okay? But because this minus sign is in front of the parentheses, I'm going to change the sign of every chunk from there on out. So this 2x cubed is going to be a negative 2x cubed. This negative 7 is going to change to a positive 7. 3x squared is going to become negative 3x squared. And x is going to become negative x. I've written it all out. That wasn't too bad. Now the final thing I'm going to do is combine like terms. Okay, I always like to start with the biggest one. So I've got a 9x cubed. I'm going to look at this problem and see if there's any other x cubes in it. Well, yeah, I've got one right here. I've got a negative 2x cubed. So 9x cubed, I'm sorry, I don't know why I'm writing that. I'm going to combine the 2 things. 9x cubed minus 2x cubed is 7x cubed. And then I'm going to go to the next one. Okay, so I'm going to look at the next chunk here. Well, I've got an x squared right there, 4x squared. I'm going to look for anything else that's squared. I've got a negative 3x squared. So 4x squared minus 3x squared would give me plus 1x squared. Keep going down the line. I've got a negative 2x, and I've got a negative 1x. So negative 2x minus 1x would give me negative 3x. And then to finish, I've got this 3, and I've got that 7. Add 3 plus 7, it gives me 10. There's that one. Number 6, we're factoring. Okay, looks a little bit hard. It's really not that bad. All right, when we're factoring here, we're going to set this in. There's nothing they have in common. 81 and 49, there's nothing they have in common. This, to me, is just one you remember. It's kind of a trick one. Not really trick, but different. We're going to split it up into 2 binomials. Okay, that means a set of 2 sets of parentheses with 2 parts each. Okay, I'm going to have 2 parts in here when I get done. So, start with the first one. We're going to split it into 2. So what it's going to look like is we're going to basically square root that thing. And it's going to be the first part of both of these. So the square root of 81 is 9. And the square root of y to the 16th, remember when it's square root of y to the 16th, that's like cutting it in half. It's y to the 8th. Okay, there's the first part. Then we're going to do the same thing with the second one. We're going to square root 49. The square root of 49 is 7 and 7. This problem is called the difference of squares. It's just something, again, memorize it if you help yourself out with it. Okay, one of the 7s needs to be positive. The other 7 needs to be negative. Okay, technically what we're doing here is we're factoring. It's a quick factor that if you memorize it, it's probably the best. Okay, that's my final answer, that thing right there. But why we did this, and you can always check your work, technically if you multiply this back together, if you refoiled it out, it'd get you 81 y to the 16th minus 63 y to the 8th. And then the other one would be a plus 63 y to the 8th. And the last one would be minus 49. Notice the reason we have one being positive and one being negative is those two things would cancel each other out, which gets me back to that 81 y to the 16th minus 49. This thing and this thing. Okay? Again, this is the answer to the problem. All right? It's a quick one. Remember, just take the square root of both of them, and the second one, make one of them positive and one of them negative. That's the key to success there. That looks like minus, or looks like equals. It's a minus sign. Last one on the front side. I got to zoom out a little bit. A rectangle has a width of 3x plus 2 and a length of 2x minus 4. Okay, so I'm going to draw a rectangle. It has a width of 3x plus 2. So this side of the rectangle is going to be 3x plus 2. The length, okay, so the long side of it is going to be 2x minus 4. All right, and know what you know, use what you know about triangle or rectangles, sorry. The opposite side is going to be the same. So if this side is 2x minus 4, so is this side. All right, and if this side is 3x plus 2, so is this side. Our job here is to find the perimeter, okay? Perimeter is easy. If you forgot, draw a little picture. Okay, let's say I had a rectangle like that. If I wanted to find the perimeter, all I would need to do is add 2 plus 3 plus 2 plus 3. I would add those 4 things together. Well, that's all I'm doing here. I'm adding those 4 things on the outside together. So I'm just going to stack them all up. 3x plus 2. Okay, I did that one. And then I'm going to do this one. Plus 2x minus 4. Plus 3x plus 2 again. Plus 2x minus 4. I'm going to add them all together. So 2 minus 4, change colors, sorry. 2 minus 4 would be negative 2. Plus 2 would get me to 0. Minus 4 would get me to negative 4. Then I'm going to add the x's. 3x plus 2x would get me 5x. Plus 3 more would get me 8. Plus 2 more would get me 10. There's my answer, 10x minus 4.